would like to thanks to the board of the ISA and the organizers of the ICA conference. It is a pity that we have to postpone our ICA in this difficult time of pandemic, but it's lucky we can still meet online. So thank all of you for coming today to attend this online seminar. My spoken English is not very good, so maybe I cannot make myself so clear. You can just interrupt me or ask me questions anytime if you want. Today, I will talk about Dune Bistability. Okay, so I will talk about Dune Bistability and critical transitions in Chinese dunes. It is a case study about long-term alien environmental change in the Chinese desert. So in this talk, I want to briefly introduce the desert and the desert in China first. And then I would like to talk about a relatively long history of environmental change, at least from the late Pleistocene to Holocene. This is an important context for the dune bistability and critical transitions during the Holocene. So at last, I will conclude with some brief implications. As you know, China is a large country, and the sand dunes expand across more than 1.3 million square kilometers in northern part of China. The precipitation in China decreases generally from the southeast to northwest, as it is dominated by the Asian summer monsoon circulation. So the distribution of Chinese desert and dune field is influenced by precipitation. So in China, we actually classified the arid desert in the west from the semi-arid dune field in the east, based on annual precipitation and their vegetation coverage. For example, the four major dune fields, namely the Mu'uz dune field, the Ochindak, the Horchin, and the Hulunbuir dune fields, are located in the east part of northern China. The precipitation in this dune field are ranging from 450 millimeters to 200 millimeters. In comparison, the Tengger Desert to the west has precipitation less than 200 millimeters. So as a result, the dune field has distinct landscapes from the desert, actually. For example, the dunes in the Tengger are mostly active. They are large, mobile barkens, transverse dunes, but in the Mu'uz dune field, vegetation cover is high in the stabilized dunes. For example, there are parabolic dunes, and they are coexisting with the barkens. The barkens and transverse dunes have really low vegetation coverage. So the stabilized dunes and active dunes has large differences in their vegetation coverage, but they are actually coexisting with each other and often forming mosaics as seen from the high-resolution satellite images. The bare active dunes are forming sand hills, and they are neighboring with the stabilized dune, which often forms large vegetation patches. So dune bistability can be largely influenced by the vegetation cover. These two kinds of dunes have different vegetation coverage, and they have different level of mobility, but they can appear and coexist in the same area with the same environmental conditions. How this kind of unique alien landscape formed and when it formed, it's really an interesting question to be answered. This question is particularly important considering that China has implemented several sand fixation projects to combat desertification in these regions. This kind of ecological restoration project is probably one of the largest in the world. It has as long as more than 6 decades effort actually, and it leads to fruitful outcomes. However, the future sustainability of this desert ecosystem still have large uncertainties. So to better understand how the alien environmental change in this desert in response to climate change, as well as human interference, is very important to anticipate their future change. In fact, the desert research in China has also a long history, at least since as early as 1959, I think. A group of scientists led by Chu Ke-zhen, a very famous scientist in China, they began to investigate the desert in China. And a lot of achievements, including many books in Chinese, have been published. So my work is basically based on these pioneering works and also some recent innovative works by Chinese scientists. I focus more on the semi-arid dune fields, especially the Mu'uz dune field. But I also carry out field works with my colleagues in the Holchin Desert and in the Ochindak Desert many times. My first time of the field trip to the Mu'uz dune field was in 2008. So since then, I have been revisited these places almost twice or three times a year. So in the last more than 10 years, we actually have collected thousands of samples from more than 100 dune sections in this dune field. So this map shows the field route in 3 years from 2010 and 2012, which cover most area in the dune field. We have even more field works and field monitorings using, for example, UAV and other equipment in recent years to monitor the dunes. The most important sedimentary record we collected in the field is this kind of dune stratigraphic sections. Dune sections in semi-arid dune field of northern China are characterized by alternations between the aeolian sand layers and the paleosoil layers. They actually record changes between an active state and a stabilized state of the dunes. Actually, sand was deposited when the dune was largely mobile at a given site, while paleosoil corresponds to the intervals of local dune stability. Here is another example showing that the paleo-dune deposits buried by the loess in the transition zone between the desert and the Chinese loess plateau. It is a strong evidence of dune expansion onto the loess plateau during the historical times. So besides the dune sections with stacks of paleosoil of sand layers like this, we could also find some other geological evidence, such as sandwiches, actually. This kind of evidence actually indicates the coldest and driest LGM period in the dune field. So all these sedimentary records, including some lacustrine and fluvial sections, are really valuable archives that can be used to reconstruct the past aeolian environmental change in these regions. Among them, I think I focus more on aeolian deposit. So in the field, we took a lot of sediment samples from the paleosoil and the aeolian sand layers. These samples were used to do the chronological analysis to determine their depositional age. We also did some sedimentological and geochemical analysis when necessary. We took samples from the outcrops, and we also took drilling samples if there is no good outcrops. So in the lab, we use the optically simulated luminescence called OSL dating technique to determine the age of the dune deposit, so that we can constrain the exact timing of changes in dune activity. The OSL technique has been largely improved in recent years. It's mainly based on the principle that the luminescent signals are stimulated by the environmental radiation. So when the sand are transported to light, they are exposed to light. So only a few hours of sunlight bleaching, their luminescent signal would be fade and close to background. But after the burial of the dune sand, luminescent signal can be accumulated again and can be measured in the lamp to determine the time since its burial. So it is the basic principle of the OSL dating. Actually, the pioneering study was done by Zhiwei in 1982, I think, to date the dune in the Thar Desert of India. Since then, the luminescent dating technique has developed significantly in the past few decades and becomes probably one of the most widely applied dating method to date dune record. Actually, we have a good laboratory in Nanjing University. We have 3 OSL readers. So our analyses are mostly done in our own lab. But in early years of our study in the desert, we also have done some comparable study in the lab of Peking, for example, and the University of Nebraska and Oxford. So here I want to mention, before the analysis with the USL reader, each sample has been processed with a complicated chemical pretreatment procedure. It is really a lot of work in the lab to get each edge of the sediment. So here is an example that showing the edges we obtained for typical dune section. These edges are really nice, in fact, and they are generally in accordance with the stratigraphic sequence. The timing of the Paleosoil indicated by the green color, and the sand layer indicated by the red color can represent the phases of stabilized dune state and active dune state in the past, respectively. So using this method, we did a lot of work and measured many dune sections to obtain precise independent edge control for these sections. Based on this record, we can actually get almost a whole picture of the spatial and temporal changes in paleo environment in this dune field. We can test the link between the changes in paleo environment with external forcings. For example, we can test the hypothesis proposed for a long time in 1978. That the global dune activity can be linked with global climate change. Although at that time, there is no real direct chronology. And actually the evidence from the East Asia is really rare. Based on many independent records, the quaternary scientists in China has established a good relationship between global climate change and Asian monsoon circulations. For example, at the glacier and interglacial timescale, this Greenland ice core delta oxygen 18 are used as an indicator of temperature change in the high latitude of northern hemisphere. During the LGM, around 26 to 15,000 years ago, the Asian monsoon was weak in response to the colder global temperature. So the monsoon precipitation in the north part of China is less, while the wind speed is stronger because of stronger winter monsoon. However, in the Holocene, the warmer global climate has caused a stronger summer monsoon. So the dune field can receive more rainfall compared to the LGM. And at that time, the winter monsoon was weaker. So the wind was weaker in the dune field at that time. So this kind of monsoon variations and interglacial time period should have significant impact on dune activity in northern China. Indeed, our alien record in northern part of China, in the dune field of China, show good agreement with the monsoon variations and broad global climate change. The alien sand was deposited around 20,000 years ago, corresponding to the coldest time of the LGM, actually, and indicating that the dunes were active at that time. In comparison, since about 11,000 years ago, Paleosoil began to form, and as a result of the warmer and wetter climate conditions during the Holocene in northern part of China. Here is another example showing the same temporal pattern. You can see the alien sand was deposited near the end of the coldest phase of the LGM period, and then it is buried by the deglacial ice, and then Paleosoil formed during the Holocene. So these two records are actually located in the northern Loess Plateau, or say the transition zone between the desert and the Loess Plateau. And present, no active dunes appear there, and the geomorphology there is mostly Loess hills. But based on this record, we can infer that the desert, at least the Moonwoods dune field, was expanding onto the Loess Plateau. And we can precisely reconstruct the shift of desert boundary, which is not very large actually, compared to its present conditions. Here is the edges of the buried dune sand in total, and based on these edges, we draw the line of the LGM expansion of the Moonwoods dune field. By comparison with other records, for example, the marine record of the winter monsoon stress, we can infer that during the LGM, the East Asia winter monsoon was much stronger. However, the summer monsoon was weaker. And after about 15,000 years ago, the winter monsoon wind was weakening. So the expansion and the retreat of desert should be responding to the winter monsoon variations. So entering into the warmer and wetter Holocene time period, most dunes in the Moonwoods dune field were actually stabilized. This conclusion is supported by the edges of the Paleosoil that was developed during the different time period of the Holocene. Actually, if you go to the dune field and find the sections, you can find many layers of Paleosoil that were buried by the dunes. These Paleosoil were formed in different time period of the Holocene. and the most developed Paleosaur was dated around 8 to 6,000 years ago, indicating a widespread dune stabilization at that time. So by plotting all the edges of Paleosaur especially, it is clear that the mid-Holocene Paleosaur was formed in a large part of the dune field, indicating a widespread dune stabilization at that time. Independent reconstruction, such as the pollen record, as well as other records of, for example, the lake level changes, all reveal that an increase in monsoon precipitation since about 15,000 years ago, and the monsoon rain belt migrated towards the northeast to the dune field. Thus, this dune field stabilization is believed to respond to the maximal monsoon rainfall and time, especially around 8 to 6,000 years ago. So here so far, it seems that the changes in dune field activity during the past 20,000 years can be well related to the monsoon dynamics. However, the nature never fails to surprise us. The complexity is also found in the dune record. For example, the late Holocene climate I just mentioned in northern China is towards regional aridification. So the monsoon precipitation is actually decreasing during the past 5,000 years, and it has been recognized by many other independent records. Indeed, this kind of regional aridification trend has resulted in dune reactivation at some time and at some site. For example, this slide shows a clear sand deposit occurred around 3.7 thousand years ago. However, the dune at this site has also experienced several times of transitions between active and stabilized state during the late Holocene, despite the long-term trend of drying climate. So in comparison, some other sites actually remained active until about 2,000 years ago, while at some other sites, the dune was reactivated since about 4,000 years ago and remained active state afterward. So these three sites are all from the Muwu's dune field, but they really show different history of past dune activity. You can see similar pattern from other dune fields as well. For example, these two records were from the Holocene dune field. They also have different trajectories of changes in dune activity during the Holocene. So the section in the left has experienced transitions in the late Holocene, while the dune in the right, you can see it remained stabilized for most time of the Holocene and became active until about 1,000 years ago. So in other dune fields, such as the Ochindok, my colleague Ya Li also found similar evidence of strong heterogeneity of dune activity between individual sites. You can easily find two different dune states and in the same time period. For example, in this site, you can see around 2.7 thousand years ago, alien sand was deposited. However, in this site, Paleosaur was formed around 2,000 years ago. So similarly, the record from Hulenbeer dune field by my colleagues Lin and I, we published a paper several years ago. We found that the strong heterogeneity of the dune activity between individual sites was also present in the Hulenbeer dune field. So we can actually generate a large dataset of dune chronologies because the number of studies dating the dunes in northern China has been increasing rapidly in recent years, not only from our group, but also by other scientists in China. So we are able to collect all the published data to study the temporal pattern of the shift in dune activity at individual sites. In the Muwu's dune field, for example, the phases of active dune state and stabilized dune state are shown by the yellow and brown columns or bars, respectively. So in this figure, three important phenomena are clear. First, actually, we can observe strong heterogeneity of the Holocene dune activity at individual sites. Second, in the same time window, we can observe that the active dunes and stabilized dunes were coexisting at different sites, although this site might have similar environmental conditions. Third, as I said before, the monsoon precipitation is believed and the predominant control of the changes in dune activity. The monsoon precipitation has been increased and decreased in the Holocene. However, the response of each site of each individual site show hysteresis in response to the gradual monsoon change and abrupt shift at a certain point. This kind of critical transitions is also varying between the individual sites. For example, the timing and the rate of the transitions are different among these sites. I also examined the other published chronological sections in this dune field. Actually, in total, we have collected more than 500 independent edges from 144 sections from the dune fields in northern China. They are mostly Holocene dune records, and among them, 76 sites was reported by a group, and the others are reported by other researchers. Here, we actually used a new site-specific approach to synthesize this large dune chronological dataset. In general, we applied different ways to indicate the time of sand deposition and soil formation. This method partially avoids the problem that might arise from different sampling strategies and in density for dating at individual sites. So we can also estimate the error in calculating the percent of active or stabilized dunes. More details can be provided in this paper. And the results are actually similar among these dune fields, that in each 1,000 or 500 years time window, you can find that stabilized dunes and active dunes were coexisting throughout much of the time, except for the 6,000 years ago when the dune field was largely stabilized. We argue that this spatial distribution of active and stabilized dunes are apparently random. They didn't follow any clear climatic gradient, actually. Instead, we think that they are more consistent with bistability that is derived from the internal dynamics of a dune system. So here we come to the concept of dune bistability. So the coexistence of two different dune states in the past is very similar to the present situation. Actually, the mechanism hidden behind this phenomenon had puzzled me a lot for a long time, until I came across a very nice paper by Professor Tosa. In that paper, the complexity of dune dynamics in response to climate change was first mentioned, I think. Although at that time, the concept of dune bistability was not yet mentioned, but this paper hypothesized that the vegetated dune can show hysteresis behavior in response to the wind speed change. Later, I came across another very nice paper by Heather Isaac and the Eastleigh scientists. They tried to use mathematical models to explain the coexistence of the contrasting dune state. This paper was published by PRL and was really lucky to have a chance to meet Heavy. I think it's also in the 8th ICA conference in Lanzhou in 2014. And we had a very nice discussion. So since then we become very good collaborator and we work together since then. And I kept explore the mechanisms of dune bistability. And actually I realized that this concept of alternative stable state actually comes from the bifurcation theory, or more recent catastrophe theory in physics, which provide a really useful framework for understanding the dynamic of the complex system. Actually, many climatic and ecological systems are complex systems, and they may have alternative stable states. Some very early application of alternative stable state theory was in the field of ecology. The ecologists successfully explained the alternative equilibrium in shallow lakes and abrupt transition between the clear state and turbid state under small perturbations. They also proposed that several major ecosystems, including the desert and grassland, might be alternative states. And although empirical evidence are still needed to approve it and describe its dynamics. Furthermore, the alternative stable state theory is also very important in terms of inferring the systematic resilience and identifying the early warning signals of state transition. Actually, we are still working on this part, so today I won't talk too much. But if you are interested, you can read this really nice review article. So before applying the alternative stable state theory to explain our geological record, we also use remote sensing to identify and characterize dune bistability first. We use the unmanned aerial vehicle to map the vegetation coverage in the site, where the stabilized dunes and the active dunes coexist. We found that the active dunes, as you see from here, that the Balkans that are being transformed into parabolic dunes, they have vegetation coverage of only about 5%. However, the neighboring stabilized dunes have vegetation coverage about 40%. We also analyzed the landscape. We analyzed the landscape images of a larger area, and it shows clearly a bimodal distribution with one peak around 5%, indicating the active dunes, and another peak around 40%, indicating the stabilized dunes. Besides that, you can see that the boundaries between these two different dune states are sharp, probably indicate the abrupt transition between these two dune states. However, actually, these boundaries did not change much in the past 20 years, indicating that these two dune states are relatively stable over time. Here is another example from the very south part of the Tundra Desert, where the recent precipitation can reach to about 200 millimeters. This kind of bimodal distribution of the vegetation coverage also indicates the two dune stable state. Although here the percent of the active dunes is much higher than stabilized dunes. Moreover, we found that such bistable dune systems are widely distributed in the monsoon dune field across the precipitation from about 400 millimeter to 200 millimeter. The spatial distribution of this dune steady state actually do not display a clear relationship with any climate gradient, for example, the decreasing precipitation. It again indicates that dune bistability is probably derived from the internal dynamics of the dune system itself. All these lines of evidence are actually in accordance with the theory of the alternative stable state and model predictions. So based on the alternative stable state theory, there should be some positive feedback loops that can maintain the initial state despite of changes in external conditions. For example, in a simple system where only one equilibrium exists for each condition, the system state can change smoothly or abruptly in response to changes in external conditions. However, if there are two equilibrium exist, a positive feedback can hold the initial state despite of changes in the external conditions. However, if the system is close to this kind of so-called bifurcation point, a slight change in condition might induce a catastrophic shift, abrupt shift to the lower alternative stable state. So if you try to restore the state onto the upper alternative stable state by the means of reversing the conditions, the system shows hysteresis, and the backward shift only occurs if the conditions are reversed far enough to reach the other bifurcation point. So in the dune system, positive feedback loops actually exist in the conditions where the precipitation is high enough to maintain the growth of vegetation. So once the plant successfully established a pinch, for example, like here, it can actually reduce the near surface wind speed, it can restrict the wind erosion, increase soil moisture, so that the dune would be stabilized, and there would be less shade barrier. So the formation of the soil can further encourage more vegetation growth. So on the other hand, if a vegetated dune are reactivated when the wind power is sufficiently high to cause the decay of the vegetation. So once the dune was activated, even relatively small wind will mobilize the sand, and the vegetation recovery would be hard due to the sand barrier. So re-establish of the vegetation would need a climate reversal to much weaker wind or some extreme rainfall event so that could allow rapid stabilization of the dunes. So this dynamics actually result in this kind of hysteresis behavior. So now we can actually apply the alternative stable state theory to explain our complex dune record. I want to repeat again, but the evidence is really clear that the contrasting dune state, the different dune state at the same time are clearly consistent with the long-term precedent of bistability and can be well explained in the framework of alternative stable theory. You can infer that the condition, the environmental condition during much time of the Holocene fall within the range of the condition from 2 to 4, where it can results in two basins of attraction for alternative stable state. The conditions in LGM, for example, could be similar to the condition 5, where only one alternative stable state and only one active state. And in the mid-Holocene, the conditions are probably similar to the condition 1, and there is only one stabilized state. So more importantly, we believe that the precipitation variations during much time of the Holocene should be within the range that for the Dune Bistability between condition 2 and condition 4. So we further analyze the critical transitions at different spatial scales, and we also find some interesting results. First, at this individual site, so this, in other words, we can say it like at multiple dune scale, we found that the timing of the abrupt transitions can be different at the nearby site. It can be resulted from, for example, stochastic perturbations and the internal dynamics of dune system. For example, the localized perturbations by, for example, the weather extremes, the fires, the animals, and human activities, then all may activate the dunes at a particular site. And the resulting active state may persist for some times due to the positive feedback I just mentioned. So this feedback can also lead to the nonlinear and locked response to environmental change, and also indicate the heterosis and the local and the individual site. However, at a system-wide scale, if we put in all the records and the 144 localities together, we can find a more granular transitions like this curve. The results show that the changes in the percentage of stabilized dunes show a broad similarity with the reconstructed precipitation and also the modeled precipitation. However, instead of a linear response, the heterosis behavior still occurs. It can be indicated by the two different cases, the early Holocene stabilization and the late Holocene reactivation is different. So we can argue that the average or the sum up of local abrupt transitions can actually produce a patterns of gradual change at a larger scale. Besides, the gradual response at this kind of landscape scale reflects that there is strong heterogeneity and a low-level connectivity among this local dune system. In other words, each dune might have their own non-linear behavior in response to the monsoon climate change. However, their overall pattern are strongly linked to the climate change. So so here it can see that the hysteresis can still be resulted from the positive feedback and multiple scales, even with substantial large local heterogeneity in the threshold and the timing of transition. The regional hysteresis could still be observed. I think our result also suggests that the analysis over multiple spatial scale might provide new insight in the nature of the Holocene landscape change in other arid regions. For example, the collapse of the Green Sahara, which could be which is more abrupt compared to the gradual change in northern China. I think the monsoon and albedo feedback in the Sahara with a larger area and probably a larger increased feedback might be important to explain this kind of abrupt transition in the Sahara. Another implications involve that we can actually apply the alternative stable state theory to identify the priority area for dune stabilization. For example, the land use management in this sandy land should be really careful, because once the dune was reactivated due to even small perturbations, they may persist and stay active, and restabilization would be almost impossible. On the other hand, once the dune are transformed into stabilized dune, for example, we use this kind of straw checkboard sedimentation, or due to climate change, less cost might be needed to maintain this kind of stabilized state if it is a favorable state. So from this viewpoint, knowledge about the climate the domains for dune steady state is really helpful in targeting appropriate regions for effective restoration. Finally, to develop early warning signals based on alternative stable state theory would be really helpful to anticipate their future transitions. Actually, one PhD student, Yaning, he is also a PhD student in Wageningen. We are now working on this part. So here I would like to finish my talk actually based on a large number of dune stratigraphic sections with independent edge control. We come to the conclusion we can reconstruct the alien environmental change in northern Chinese dune field. And we found that the dune fields are largely expanded during the cool and dry LGM period, and they were largely stabilized during the mid-Holocene in response to the Asian monsoon variations. And we argue that the dune bistability is really an important phenomenon for semi-arid dune system, and it can persist in northern China for the past 12,000 years. Especially at the individual site, we found strong evidence of a strong heterogeneity. We found the abrupt transitions and the heterosis of the dune in response to the monsoon climate change. However, at the system-wide scale, we found more smooth transition. We found gradual transition and heterosis of the landscape response to monsoon climate change. So the formation of dune stability can be well explained under the framework of alternative stable state theory. And the positive feedbacks between, for example, vegetation, soils, water availability, and wind-driven sand movement, and even monsoon climate at multiple scales are really important to explain the alternative stable state of the dune system. And at last, I want to mention that this work is actually part of the several long-lasting projects in collaborating with many colleagues in the past 10 years. I want to express my thanks to my former supervisor, Hua Yu and John Mason. They trained me as a geomorphologist and quantity geologist. And Dr. Ya Li and Dr. Shuang Wen, they helped me a lot in dating of dune sections. I recently collaborated with Heavy, and we still have some ongoing projects funded by SFC and ISF. Xu and Milana from Wageningen, they are ecologists, and Sylvester Bassiani, he is a climatologist. They also participated in this recent work. And also my master students, Yongxin Chen and Shihan Li, and also Yaning Qiu, they're also working with me now. So we are still continue on this topic. So many thanks again to Isa for inviting me to give this talk, and thank all of you for listening. And I'm ready for questions.
Thank you, Zhiwei. Anyone have questions?
Probably I talk too quick, too fast. Sorry for that.
There's a lot of information, but I also learned a lot. Maybe I can start with one question here. You talk about the, I noticed there's within a very small scale, you have these two kind of very distinct landscapes. One is with stabilized, like dunes, and the other one is active. So I'm just wondering, like, do you think there's like the groundwater table over here, that area is similar or is it different?
Yeah. It's really a good question. I didn't mention that, but it was written in the article, that in the paper, that for example, these four sites, they show really different threshold of and timing of the transition. I think it's partially because probably they have, for example, different water table level, and maybe the grain size is different, and maybe vegetation types are different on this side. So I think this kind of factors can be random in the dune field. So so they are all, this site are all responding to the monsoon variation, but because they have their initial condition are really different, so the trajectories of response can be different. Yes, I think that's really important factor.
Okay, I think we have someone in the WeChat blog has the question. So why did bistability start at 12 Ka? Why was not in the past? How did the sand supply change?
Yeah. I think this is a very good question. I studied the Dune section, or the main focus of my research is since like 20,000 years ago. There could be Dune Bistability even longer time period, because the desert was there for many millions of years probably. However, I want to mention that during the LGM, actually the dune fields are mostly active. And this kind of bistability, for example, the stabilized dune, they occurs since the Holocene time. Probably I can say it like the last phase of the dune bistability, but it doesn't mean that in the past, in the geological time period, it's not exist. It can still exist. Yeah.
Okay, another question here. How long will transition process take? Is there any possibility to capture transition processes between these based on sedimentary data?
Yeah, it's really a good question. I really want to see who asked the question, but it's okay.
It's
okay,
Yanning Qiu.
Oh, Yanning. Okay. Yeah. It's really nice question. That I think the transition, it's a matter of a time scale. I think the transition can be fast or slow, depends on, like you said, the condition of the site. Actually, we also did some remote sensing work. I have a picture here, I think. Yeah. You can see the dunes, the parabolic dunes, they are being stabilized. Actually, after a few years, even like a few decades, probably the dunes will be stabilized and transformed into a parabolic, and will be totally stabilized. So this, if you say time scale at this side probably very quick. But maybe in the other side, it needs some more time period to see this transition. So, yeah, this is my answer. And for example, in the geological record, it can be last for hundreds of years, or even 1,000 to 2,000 years to see this kind of transition, I think.
Okay, any other questions? No one? All right, so I think there's no more questions right here. Okay, hold on. I'd like to know, there are actually more questions over here. Just hold on a second. I think there's one question from Ingrid Stengel, and it said, "Thank you very much for your presentation. I would like to know the influence of the summer monsoon on river activity in terms of additional sand supply."
Oh yeah, it's also a very nice question. I didn't mention the sand supply. Sand supply is also very important control of dune development, indeed. And for example, we have a study about the LGM dune activity. We found that during LGM, and as I showed before, the permafrost was formed as evidenced by the sandwiches. And actually, at that time, the sand supply probably be limited due to the permafrost. And the dune at that time, even though they are really strong erosion and the dune activity probably strong, but the preservations of the sand could be really limited, and also the formation of the dune could be limited. However, about the summer monsoon, the most important influence of summer monsoon to this region is it brought more precipitations there. So it can encourage the growth of vegetation. So the vegetation growth will limit the sand supply, and partially because of that, I think the dune began to transfer from, for example, large dunes to small parabolic. But for the river activity, It's really hard for me to answer. But yeah, I think it will affect the dune development through vegetation. But for river activity, I don't know if the dune field the sand supply is very important is affected by river transport sand. Sorry, this question is I still don't know how to answer it.
Maybe not many
Yeah.
of the river system there, right?
Yeah, it's a good question, but yeah, it's maybe more research.
Yeah. Actually, I also have another question regarding the scale. So
Yeah.
I think you have mentioned that you are using UAV and also using the remote sensing, like Landsat images, right? So they do have different scales. So in terms of the to examine the stability and how to quantify, for example, for different scale, you probably have a different resolution, then you should have a different kind of percentage of vegetation and stuff like that. So how you evaluate which scale is appropriate for this kind of analysis?
Yeah, thank you, Bella. It's really a nice question. Actually, we also meet this trouble when we do analysis. It's actually two parts. The first is about the resolution of the data set itself. For example, as you mentioned, the resolution of the satellite images. And the second is really a matter of a scale of the feedbacks. So at what kind of scale this dune bistability exists. If it is too large, it may include some other types of land cover, for example, the river system or the lake. So we cannot identify dune bistability actually. So we tried we tried a lot of scales, including the spatial extent of the area and the resolution of the images. And finally, we found that at the spatial extent of like 5 kilometers plus 5 kilometers, use the Landsat images, which has the resolution about 30 meters, is sufficient to identify. And the result is really nice. And so based on this, we identify this bimodal distribution of the vegetation coverage.
Yes. So for me, it looked like that for the active or non-active kind of dune fields, they are more like continuous, right? So once you have this dune field, then you don't see much kind of active field in the stabilized dunes, right? So it kind of, to me, it looks like it has some autocorrelation, spatial autocorrelation over here.
Oh, yeah, you have a really nice observation. Yeah.
Right. Okay. Another questions here from Li Zhoulun. Okay. Aeolian sand deposited in paleo soil layers always indicate an arid environment. But till now, how can we consider the environmental significance of the aeolian sand deposition?
Yeah. Thank you, Jolon. Jolon is my good friend. Yeah, it's a good question, and I would say it's also a matter of scale, that the scale of climate variability. In some site, if this site really sensitive to the small perturbations from the climate extremes, for example, it may have sand deposited, for example, as you said, in the paleosoil. And it record then the shift in climate, a small shift in climate. But in the other side, probably they remained vegetated. They didn't record these small climate extremes. So I think it's also, I fall in the framework of the alternative stable state theory. And if we really want to know the whole picture of the dune field activity changes in response to climate change, we need to examine many sites, and then we make more comparison between the sites and to see if this climate extreme is really have a large impact or it's really localized. I don't know if I make clear.
Okay, I think we have another question. I mean, more like a comment from Stengel. Yeah, regarding fluvial activity, thank you. Just a final comment. I was just asking because in many semi-arid area, the sand supply comes especially from the fluvial activity during period of increase by the strongly seasonal rain. The sand from riverbed brought into the system during the rainy season is then picked up by wind during the dry seasons.
Yeah. Thank you for this comment. You mentioned about the seasonality actually of the alien processes. I think you are right. And one more thing that is also very important, that the river system in the dune field are usually their head are still within the drainage is within the dune field. So the sand of the fluvial system itself also come from the alien system. So yeah, that's my additional. Yeah, thank you for commenting this.
All right. I think there may be no more questions. So Mike, do we have any kind of any information about the next seminar?
Thank you, Zhiwei. That was a wonderful presentation. Thank you on behalf of the ISR board. Baliang, no, we have presentations arranged for September and October, but we are looking for a volunteer for July. So if anyone is interested, please contact Jan Barand or myself, and we'd be very grateful to hear from you. Thank you, Baliang, and thank you again, Zhiwei.
Thank you, Mike.
Bye for now. Just wait for emails.
Yes.
Bye. Bye.
Bye-bye. Thank you, Zhiwei.
Thank you, Mike. Thank you, Jan Barand. I didn't say hello with you. Thank you.
Thank you,
Baliang. Bye-bye.
Bye-bye.
Bye-bye.